Okay, so how about we get a problem that uses one of those feasible region problems where we get entire regions shaded in for intersection. And we're asked about calculating our max or min with some objective function. Okay, so first let's do a problem where we have to sketch a region. So what region is determined by the following? And so we've got this long list of definitions here. Okay, so this is going to be some shaded region, and I need to know what it is. Well, first of all, let's get a sketch of what these are when instead of these inequalities I have equal signs. And then we have x plus 2y equals 2. Okay, so that's going to be a line. This part here tells me we're going to be in the first quadrant, so Q1. So I can just leave those out for now. But let's see what we've got here. So on some graphing paper, and this is the graphing paper you'll be supplied with on your test. Since I'm only interested in the first quadrant, I'm going to draw my graph over here. Okay, so 1, 2, 3, 4, 5, 6. So 2, 4, 6, 8, 2, 4, 6, 8. Okay. So this tells me I'm only in quadrant 1. Okay, what does that look like? Well, that is a vertical line, x equals 4, and it goes through 4 on the x-axis. So I'm just going to draw that line in. Okay, so there's the line x equals 4. So I've taken care of those because I know it's going to be there. What does that line look like? Y equals 7. That's a horizontal line that goes through 7 on the x-axis. Okay. And now what does that line look like? Well, if I have 2 points on that line, I can draw it. And the easiest 2 points to find are the x-intercept and the y-intercept. So at the y-intercept, we have x is 0. So if x is 0, this equation becomes 2y equals 2. And so y is equal to 1. So I know it's got the point 0, 1 is on the graph of that line. So there's 0, 1. And what happens if y equals 0? So if y equals 0, this equation becomes x equals 2. So I know that the point 2, 0 is also on that line. If I have 2 points, I have the line. So I'm going to color in 2, 0. And then I would take a straight edge, a ruler, but here I've got folded paper, and I would just draw that in. Okay, now we know that we are restricted to the first quadrant. Okay, so that's the first thing. And x less than or equal to 4 is going to be everything to the left of this line. And y less than or equal to 7 is going to be everything below this line. And then I just have to figure out what region am I in with the line. And so I can subtract x from both sides. That does not change the arrow. I can divide everything by 2. And that does not change the direction of the arrow. And so I'm going to want the region above this line. So first quadrant to the left of this, beneath this, and above this. So only first quadrant, and this is my region. So my final answer, I should only have that region. So if you were busy coloring in other regions on another piece of graph paper, if this were on the test and I wanted to see the region determined by that particular set of definitions, this is what we're going to get. And clearly, okay, this is not included. So I'm going to get this shape. Okay, now, what if I get asked about the objective function, a question about it? So for this region, calculate the max, or the min, of the objective function. Our book uses z. But this is a function with x and y, so I prefer this notation. Well, what you plug in here for x and y are your vertices. Now, where are my vertices on this pink shape that I have shaded in? There's a vertex, a corner. There's a vertex. There's a vertex. There's a vertex. And there is a vertex. Just got to be careful. I want to make sure this bleeds through. Okay, now, what are the coordinates of these points? Well, should be easy to read off. This point has x coordinate 4, and its y coordinate is 7. What about this? This is 0, 7. What about that point? That is 0, 1. That point is 2, 0. And this point is 4, 0. So the vertices, the corner points, are the ones I plug into the objective function. So I'm going to need to test this with 0, 7, 4, 7, going clockwise, 4, 0, 2, 0, and 0, 1. Okay. So, plugging this into the formula, I have 5 times 0 plus 3 times y. Plugging this one in, I have 5 times 4 plus 3 times 7. So I'll have 20 plus 21, which will give me 41. This one, I'll have 5 times 4 plus 3 times 0. And this one, I'll have 5 times 2 plus 3 times 0. And this one, I will have 5 times 0 plus 3 times 1. So here's my max. And there's my min. So I have a maximum value of 41 at the vertex 4, 7. I have a minimum value of 3 at the vertex 0, 1. Okay, so that answers that question for this round. Okay, so let's see what we could do if we've got some different definitions. So I'm going to pause this and look to see if there's another one. Okay, so let's start with a new problem. First, whoops, let me get this back on the screen. First, let's determine the region that we get with these definitions. Okay, so what we want to see is we want to recognize what these are when we have equal signs. So they're all going to be a line of some sort. Okay, so let me get a sheet of graph paper. Oh, okay. I'll get my axes. Okay. So I'm looking for the line x equals 4. So that's a vertical line that goes through 4 on the x-axis. Okay, so I'm going to draw that. Then the line y equals 0 is just the x-axis itself. Okay. Okay. Then I want this line x plus 2y equals 2. Now, that is the same line that I drew last time. And I can graph any line as long as I have 2 points on there. And so like the last example, the y-intercept is 0, 1, and the x-intercept is 2, 0. So y-intercept at 0, 1. And the x-intercept is at 2, 0. So if I have 2 points, I can draw the line. I just need a ruler or something straight, some kind of straight edge where I can connect those 2 points and then draw the line through it. Okay. So this is the line x. I'll draw it in black. This here is the line x plus 2y equals 2. Okay. And then I've got a new line, this negative 3x plus 2y equals 2. Okay, well if x is 0, then this equation becomes 2y equals 2, and so y is 1. So 0, 1 is a point on this line. And if y is equal to 0, then this equation becomes negative 3x equals 2. And so I divide both sides by negative 3. And so x is equal to negative 2/3. Okay. So where would negative 2/3 be? It'd be about there. And I have an intersection point there. So I can draw that line now. Okay, and so this is my line, negative 3x plus 2y equals 2. Okay, I've got them all drawn. Now I want to get my region. Okay, and my region is, I want x less than or equal to 4. That means a little bit to the left. Okay. Y greater than or equal to 0. That means above. Okay. And for this one, just because that symbol is greater than or equal to doesn't mean it's above and on. It has to stay the same when I have y by itself. So I'm just making sure that that's the case. So if I subtract x from both sides, the symbol doesn't change. And if I divide through by positive 2, dividing by a positive symbol does not change the direction of the arrow. So I will want everything above the line x plus 2y equals 2. So everything above this line. And I'm just sketching in what's in the region so far. And then finally, for this line, okay, this region, well, right now this symbol is less than or equal to, but I just want to make sure, just double check that when you get y on the left-hand side by itself, the symbol doesn't change, and it shouldn't. So I'd add 3x to both sides, so that wouldn't change anything. And then I would divide everything by positive 2. That won't change anything. So I do want, as this symbol suggests, on and below, okay, on and below this line. And so this line here, I want on and below. And so my region is going to be this. So where all of those meet, where all of those are correct. This is what I want. So what I am shading in here is going to be this region. Okay, so that would be the answer for the region that's determined by that. So this is the region I would get. Now, if I'm asked a question about minimize or maximize the objective function, okay, let's do something like that. Minimize and maximize the objective function for this region. Well, and of course our book would put it like that. Well, what do I put in here? I put in the vertices, the corner points. And how many corner points do I have on this? Okay, and what are their intersection points? This is 1, 2, 3, 4, 5, 6, 7. And so this point looks to be 4, 7. This point looks to be 4, 0. And then I have 2, 0. And I have 0, 1. So that's what I put into my objective function. So I'm going to, if I start here and go clockwise, I need to calculate those. So for this function that I've been given, I'm going to have x, which is 0, then minus 3 times y, so I get negative 3. For this particular one, I'm going to have 4 minus 3 times 7. So 4 minus 21. And so that's going to be negative 17. And here I'm going to have 4 minus 3 times 0. And here I'm going to have 2 minus 3 times 0. Okay, that's the highest one. That's my max. And out of these, negative 17 is the lowest. That's my min. So I have a maximum of 4 at the vertex 4, 0, and I have a minimum of negative 17 at the vertex 4, 7. Okay, so that's how we do problems like that. So on that very last section that I pointed out in the lecture where they're asking you to calculate maximum and minimums, that's what we're meant to be doing for that. So I will close this.